Hello everyone, this is the North American Math Contest Go Go Go, and this week we are going to work on the AP Calculus BC 2012 Public Exams first 10 problems. AP Calculus BC 2012. The first problem is given y is equals to sine x. We are required to find dy over dx. So we know that to find the derivative of this, we can set sine x as u. So the derivative of this is u to the power of 3 times the u's derivative. So this we know is 3u squared, and the u is referred to sine x, which the derivative of sine x is cosine x. Therefore, the answer for us is 3 sine squared x cosine x. And looking at the problem, we can find that this is in one of the choices, and it is in choice E, which the answer finally is E. Now let's look at the problem 2, where this problem involves in the parametric functions. So this problem, xt, yt, has a common function of equivalent to t cubed minus 3t squared, and the second one is 12t minus 3t squared. We are required to find at what time t xt, yt is at rest. So to make them at rest, we can know that it should be xt is equal to 0 and yt is equal to 0. So we can then find out the derivative of xt and yt and calculate them respectively. So since we know that the xt is equals to t cubed minus 3t squared, the derivative of xt is equals to 3t squared minus 6t. We then calculate 3t squared minus 6t, which is equal to 0. And we know that 3t minus 6 is equal to 0. Therefore, the two possible solutions are t is equal to 0 and t is equal to 2. Now let's look at the yt. The yt is 12t minus 3t squared. So the y derivative t is going to be 12 minus 6t, and we know that the only solution for it is t is equivalent to. So therefore, the only solution that is possible is t is equal to t is equal to 2. So after we know t is equal to 2, what we can do is we can calculate xt and yt. So we know that xt is equals to t cubed minus 3t squared. So xt is equal to negative 4 after plugging t is equal to 2. And yt after we plug in is equal to negative 12. There is equal to positive 12. So therefore our final solution is negative 4 positive 12, which refers to the choice A here. Now let's look at our third problem, problem 3. The graph of f is shown above. What is the value of this? This problem is generally another simple problem. So we know that 1. Let's draw the graph first. 0. And then it's this is 2, 5. So it's 2 here. and 5 there. So this is the upper part, and the lower part, on the other hand, is from here to here, where this is 4, and this is 4, and this is 4, while this is -3. So we know that to calculate the area of this, which the problem states it, to find the area of the integral fx, what we need to do is we need to calculate the upper part and the bottom part, and we minus upper part by bottom part. So therefore, our solution is going to be upper part is equal to 1 times 5 times 2 divided by 2 is equal to 2, 6. And bottom part is equal to 3 times 2 is equal to 6. So our final solution is going to be 0. Now let's look at the problem 4. Which of the following gives the length of the curve from 1 to 2? Which of the following gives the curve from 1 to the power of 2? Let's see. So the formula for the length of curve starting from y, so we now need to know that there's a formula for the area of the curve starting from y is equal to a and y ends at b. So we know that it is equivalent to a for the equation y is equal to fx. So the equation is going to be this 1 After we know this, the equation, so we know that a is equal to 1 and b is equal to 2 and fx is equivalent to in x. So therefore, our final graph will be 1, 2, 1 plus 1 over x squared dx. Okay, so this is the answer for problem 4. Now let's look at the problem 5. Problem 5 states that the Maclaurin theory for a function is given by this, and we are required to find the f3. So we find out that this problem is a geometric sequence. It is pretty clear. So it's 0, infinite, negative x over 4 to the power of n. This is the equation. So we know that negative x over 4 is equal to r. So, and in this case, r is equal to negative 3 over 4. Therefore, according to the geometric equation 1 minus r, for the infinite sequence, the result will be 1 minus negative 3 over 4 is equal to 1 divided by 7 over 4 is equal to 4 over 7, which is the choice D. And finally, let's look at our problem 6. Problem 6. Integration by problem 6 involves in the integration by substitution. We are required to find x squared minus 3 over 5 dx with the substitution x squared minus so we know that we have to put it in the x dx form. So therefore we know that this is u to the 5. So therefore x is equal to 1 over 2 du. And 1 over 2, let's put it outside, so it's equal to 2. So it will become 2. So it is 2 u to the power of 5 du. And now it will be pretty clear. And after that, what we only need to do is we only need to substitute them back. So let's look at the choices. So you should know that the final result is equal to 2 integral root 5. So it's 1 over 2. Never mind. I think I might make a mistake here. 1 over 2 root 5. Then we need to discuss about the upper bound and the lower bound. So it's the upper bound for u is equal to -2 minus 3 is equal to -2. This is the lower bound. And the upper bound is equals to 4 minus 3 is equal to 13. Therefore, the final answer is going to be this, which is C here. Now let's look at the problem 7. 7 is the example of implicit differentiation. Arc sine x is equals to in y, right? So we know that the derivative for the arc sine x is going to be arc sine x is equal to sine negative x, which is the derivative is going to be this. And in y, the derivative is going to be this. So therefore, dy over dx is equals to 1 over y divided by 1 over y minus x squared. So it's equal to y divided by 1 minus x squared. So this is the answer for problem 7. Now let's look at the problem 8. Problem 8 is a problem involving the Riemann right-Riemann sum. So therefore, this problem is just a straightforward problem because this is how you will work for the right-Riemann sum. 6.2, 6.5, 6.5. This is how the right Riemann sum works, and this is how the left Riemann sum works. So the answer is going to be 7 times minus 4 times 6.2 plus 12 minus 7 times 5.9 plus 15 times 12 times 5.6. So therefore, the answer is going to be 18.6 plus 29.5 plus 16.8. And then we know that the initial amount is 50, right? So we need to plus it with 50 is equals to 48 minus 1, 57, 107.9. The answer is 107.9. Put right Riemann sum. So for problem 8, we get that the answer is going to be 107.5, and the closest answer to that is C. Therefore, the answer is going to be C, which is 114.9. Let's look at problem 9. Which of the following theories converge? So let's look at the choice 3 first. This problem can be done through basic estimation. 3, it can be redistributed into n minus 1, n minus 2 times 1 over n plus 3. So therefore, it definitely converge. So therefore, 3 is definitely correct answer, which eliminates A and B. And 102. So I'm going to show you that one converge. Again, it's basic on simple estimation. So we know that as it approaches to infinite, 8 is time by times 8, and then it's time by time n. So therefore, this must exist this because it has a higher multiplication speed. So therefore, this must be the faster one. So therefore, the answer is going to be 1 and 3, which is D. Looking at problem 10. 10 is another basic integral problem. Ten is another basic integral problem. Let's see. 10 is another basic integral problem. So therefore, we know that the original equation, we need to find this derivative. So it's equals to antiderivative. We need to find this antiderivative. 1 divided by -2, right? So it's equals to this, right? -1, -1 times. Yes, I think it's the correct answer. Then we use the fundamental theorem of calculus here, which is -2 for -1/2 minus -2 1 minus 1/2. This is definitely equal to -2, and this is definitely equals to definitely equals to what? Definitely equals to let's see, definitely equals to -1. So -1 minus -2, it is equal to 1. So the answer is E. Here we come to the end of our first 10 problem, and I hope you have learned a lot. See you next week. Bye.